I'm going to talk quickly about the different types of radioactive emission, of which there are three. We have alpha emission, we have beta emission, and we have gamma emission. Now, an alpha particle is a helium nucleus. It is a helium nucleus, it has no electrons, and it's quite a heavy particle. It has an atomic number of 2 and a mass number of 4. Because we have 2 protons and 2 neutrons, and the atomic number is protons plus neutrons. This gives us 4 up here. A beta particle occurs when a neutron turns into both an electron and a proton. Okay, so the beta particle is the electron. Beta particle is just a fancy word for a high energy electron. Now, when this is given off, the atomic number of the element that's left over goes up by 1, and the mass number stays the same because the mass number is protons plus neutrons. Okay, so we'll get back to that in a minute. Gamma radiation is high frequency, high energy electromagnetic radiation. Okay, it has no mass, therefore no atomic number, no mass number. So let's figure out what happens in each of the cases. If we start off with uranium-234, an unstable isotope, when we emit an alpha particle, then we remove 4 from the top number, so that will be 230, and we remove 2 from the bottom number, which is 90. This is going to leave us with thorium. Now, you don't need to know which element is given off, you just need to figure out the numbers. When a beta particle is given off, let's pick rubidium, which has an atomic number of 37 and a mass number of 88. When we give off a beta particle, the mass number goes up by 1, so that'll be 38, and 38 I think is SR, which I think is strontium. And the mass number on the top stays the same. Okay. Now, gamma radiation, when gamma radiation is given off, the number stays the same. So if we start off once again with uranium-234, if that gives off some gamma radiation, then we're still left with exactly the same thing. Still a little bit too unstable, so it's likely to further decompose after that. Now, what other information do we need to know about? We need to know about the penetrative power of these different different types of radiation. So the penetration power, so let's just call it penetrative power, it will take paper or skin to stop alpha. So it's not that penetrating. Its mass is relatively heavy compared to the others because it's got an awful lot of mass there. But it's also highly ionizing. This is the most dangerous if ingested because it's highly ionizing, it's missing 2 electrons, so it's going to go grabbing 2 electrons off everything it can find. So if you were to drink some of this, you'd be seriously ill due to the radiation. Okay, so but thankfully it can be only travels a little distance because it's very heavy, and it can be stopped by paper or skin. Beta radiation, on the other hand, will be stopped by 2 to 3 millimeters of aluminium. Its mass is relatively light. Its electron, which is tiny in comparison to a single proton, let alone 2. But it'll be stopped by 2 to 3 millimeters of aluminium, so it's still quite dangerous. It's only lightly ionizing because it's a high energy electron, so it can still do you quite a lot of damage. And then gamma will be stopped, it will take absolutely meters of lead. Okay, a very dense material, virtually unstoppable, this stuff, because it's very high energy photons of gamma radiation. Okay, electromagnetic radiation. Its mass is 0. Light doesn't, in this case, weigh anything. It's not as ionizing, so the most dangerous is this. Okay, you are extremely dead if you ingest some of this. This is still not so bad, so we will still draw a sad face. It's still a little bit ionizing, but not as bad as this. Okay, gamma radiation is not as ionizing as the other. So these smiley faces, don't know what kind of physics scale this is really, but most ionizing to least ionizing down here. Okay, hope that's helpful.